All right, hello, and welcome back to the OneClass Live channel. Again, my name is Joey. I'm going to be your Algebra 1 teacher for today's lesson. And again, uh, just a little bit of background and introduction about myself. My name is Joey. I'm currently an intermediate senior division teacher candidate at York University. So I'm hoping to pursue I'm almost very close to being a certified teacher at this point now, and my main teachables or main subjects of interest are chemistry, so in science, and also in music as well. But I'm hoping to get my math teachable further down the road. A little bit about OneClass again. OneClass here is what we're doing is we're providing free online lessons and videos and tutorials of classes in secondary, that's at the secondary school levels, specifically through math and in chemistry. And what we're doing here is we have a bunch of teachers here at OneClass to help you out, to help tutor students and to help teach concepts that might not be familiar with. So if you're a student tuning in, or if you're a parent tuning in, thank you I'll just give you a shout out. So thank you for watching. And also, I hope you find this is useful information for your students or for your kids at home as well. So without further ado, let's get started with our lesson for today. So today's lesson, what we're going to do is what we talked about before was we talked about one-step, two-step, and multi-step equations, and I realized that I forgot to do a concept that's kind of out there actually, which is it's not very particular to variables, algebraic expressions, and equations. But we forgot to talk about this topic of percent of change. So let me just briefly go over this before we go back and review some multi-step equations. So let me do percent of change, and let me just define percent of change for you. So this here is percent of change. And what is percent of change? So basically what it is what is the percent increase or decrease? So percent of increase would be, I'm just going to use it, and this is a percent symbol that we're very familiar with, of increase would be something like this problem here. From 45 feet to 92 feet, obviously 92 is bigger than 45. The initial number is smaller, right? So there's a percent of increase, right? So it's getting bigger. The numbers in this case are getting bigger. Numbers getting bigger. And then obviously if there's increase, there's obviously a decrease, right? And so when we talk about percent increase, like this quarter, Apple had this percent increase, a 50% increase. It means that they made a half of what they initially had, right? So, and then obviously if they had percent decrease, they lost half of what they had, right? So number is getting smaller, right? So how do we figure out this percentage? So let me do this first question here, and maybe I'll give you a little definition of how we do this problem, and I'll try to break this down to steps for you. But I'll do an example to show you what that means. So this is from 45 feet to 92, right? So 45 feet, and the units are important as well. 2 is to 92 feet. So in step one, what we do is I'm going to break this down to steps. So step one, what are we doing? We are finding the difference between the final number, which is 92 in this case, and the initial number, which is 45. So we're finding the difference, which means we are subtracting. So let me subtract 92 from 45. So 92 feet minus 45 feet would equal, take out my calculator real quick. Actually, I can do this in my head. This would be 47 feet, right? It's 47 feet. Training my mental math on this lovely Saturday morning here, or Saturday afternoon. Technically in the Eastern time. So it's 47 feet. And what we're doing is we're going to take this number. Now step two here is we're going to take the difference and we're going to divide it by the initial. So this here, step one was, let me do this in black. Step one was find difference. And what we're doing is now with difference. So step two is with difference. So with difference, we're going to divide difference by the initial. So divide difference by initial. And what I mean when we talk about initial is this number. When we talk about this word initial, it's this number here. In red is the initial. And when we talk about final, it's this 92, the final number, right? And the difference here, difference in this case in blue is 40. This is the 47, right? So let me do that. So I'm doing, what is the mathematical operation I'm doing? I'm dividing the difference by the initial. I'm taking 47, which is the difference is what we have. The 47 was our difference here. And what we're doing is we're dividing it by our initial, which was 45. 45 here was our initial. So I can't do this in my head. So 47 divided by 45 would be, let's check that out, and be 1.04. 44444. So I usually do about, I'm going to take about 3 decimal places. So 1.044. So that's my decimal. And then obviously with the decimal for step 3, what I'm going to do is I need a percent, right? So I'm going to have to change my decimal into a percentage. So step 3 would be, let's look here. So I'm going to do change decimal into percent. I'm just using a percent symbol. And how do we do that? Remember, if we remember from decimals to percentages, we would have to multiply by 100%, right? By 100%. So in this operation, what I'm doing is I'm taking the decimal, which is 1.04. So 1.044 times 100%. So I'm moving this decimal 2 places to the right. So 1, 2, I'm going to 104.4%, and I'm going to round this to the nearest percent, which is 104%. And that's going to be my answer for this question. So 104%. So 104%, and is it an increase or a decrease? Let's look back to our question. It's from 45 to 92. The number is getting bigger, which means I have a percent of increase here, right? So I'm going to say here, I can write here for my final answer, I have 104% increase. That's been my answer for number 1. So let's do a couple more, and then we'll kind of switch gears in the middle of our lesson and do questions with equations again. I just want to kind of go back to this topic because it is in the curriculum, and I want to go over through it, and it's because I missed it, so that's kind of my bad. So let's do that. So let's do every other one. So let's do question 3. So question 3, oh, sorry. Question 3. We have from 74 feet to 75 feet. So 74 feet to 75 feet. So first off, is the number getting bigger or smaller? Maybe I'll give you about a minute. If you're on the chat, please maybe wave hi, and let's approach this problem together. So let's I'm gonna give you about 1 minute to see if we can come up with an answer, and then I'll walk you through what I would do in this problem. So take a minute, and if you're in the chat, maybe wave hi, and maybe give out some answers as to or some prompts as to how to think about this question. So I'll give you about a minute to do that. So again, my first step here is let's determine if it's an increase or a decrease. Is my number getting bigger or smaller? 74 to 75, again, the 75 is a bigger number than 74, obviously. So this is an increase. Increase here. So this is a percent, we're finding a percent increase. So again, let's follow my step 1. So step 1 states that I need to find the difference between my final and my initial, right? This here is my final number. Final number. This here is my initial number. And what I'm going to find the difference between these two numbers. So I'm going to take the final minus initial. So step 1 again here is final minus initial, which means 75 minus 74, which equals 1 in this case. And 1 is my difference, right? So I'm going to define this as my difference here. And then what I'm going to do is step 2 says that I need to divide my difference with the initial, right? So again, I'm taking my difference and I'm dividing it by my initial. So I have here, this is 1, which is my difference, and my initial here is 74. So 1 divided by 74 is, let's see, 1 divided by 74 is, I'm going to take 3 decimal places, so 0.10134. So that's going to be my decimal. And then step 3 is I have to multiply decimal by 100%, multiply by 100%. So which would be, in this case, it would be 0.0134 times 100%. I'm going to move when I multiply by 100, I move the decimal 2 places to the right. So 1, 2, and then I get here 1.34%, and I'm going to round it to the nearest percent in this case, or I'm going to round it actually to 2 decimal places because I was only given 2 digits. So this is 1.3% would be and this is percent increase, right? Increase would be my final answer for this problem. This is 1.3%. And technically for this problem here, I would have, because I was only given 2 decimal places, so I would have technically wrote, in this case, actually no, I would have wrote 104% regardless, because I wouldn't be able to show that. I would have to show it in that scientific notation, which we haven't talked about yet. So we won't talk about that probably in this course, but don't worry about that. It's just how many decimal places we take. So let's do number 5 here. 5. It's going from, this is from 94 miles to 34 miles. So again, increase or decrease? Do I get a percentage of increase or percentage of decrease? From 94 to 34, I will get a percentage decrease, right? My numbers are going down. So this is a percent decrease. And then now I have to follow my 3-step formula, right? My 3-step formula states that number 1, what do I have to do first? Number 1 is I'm going to have to find the difference, right, between the final and the initial. So in this case, it's 34 minus 94, right? Remember, this is the final and this is the initial, right? This here is the final. It's always final minus initial. So final, this is initial. So final minus initial. In this case, 34 minus 94, I get a negative number. I get negative 60. So that's going to be my difference here, right? Difference. And then what I'm going to do, I have to divide my difference by my initial, right? So in case our difference here is negative 60, I'm going to divide it by this initial, which is 94. And what do I get? Negative 60 divided by 94 equals, this is negative, I'm going to calculate negative 0.638, and I'm going to take 3 decimal places again. And then what I have to do, my last step here is I'm taking this decimal, I'm going to multiply by 100%, right? So this is negative 0.638, sorry, 638 times 100% will give me, this would be negative 63.8%, right? Because I'm moving decimal 2 places to the right. So in this case, this negative, I have a negative percent. This negative just basically states I have a percent decrease, right? So this negative, I'm going to translate it into a percent decrease. So I'm going to get rid of this negative and replace it with a word decrease. And I can say this is 63, or I'm going to round it to the nearest percent. So in this case, this is 64%, and this would be a decrease. And that's denoted by my negative number. And that's going to be my final answer for number 5 here, 64% decrease. Okay, actually, no, I think I forgot to put in miles here, so sorry about that. This is miles. Miles is just to make my units nice and clear here. Okay, let's maybe do a couple of further down ones, and then we'll review our equations. So maybe let's do 2 or 3 more, depending on how much time. Let's do 19. And these numbers are a bit bigger, so I'm hoping that it's somewhat harder, but I don't see it being harder. This is 309 grams, and I'm going to write G for grams, and it's going to 299 grams. So percent increase or decrease. So it's going to take a minute to figure that out. So what we're saying is, in this case, 309 to 299 would be a percentage decrease, right? I have from 309 to 299 is clearly the number's going down. So I have this is a percent decrease, which means I'm going to get a negative percent, as you saw from the last problem here. So again, step 1 is find difference between final and initial, right? Final in this case is 299 grams minus initial here is 309 grams, right? So if I subtract the two numbers, I'm going to get negative 10. This is grams. Negative 10 grams. And then what I'm going to do is I'm going to divide this difference by the initial, right? So that's step 2. Divide negative 10, which is my difference, divided by my initial, which is 309. And then I'm going to get, so this is negative 10 divided by 309. I will get negative 0.032. So negative 0.032. And then what I'm going to do is I'm going to convert this decimal into my fraction, right? So, sorry, into my percentage. Why did I say fraction? So 0.032 times 100% will give me some sort of percent, right? I'm going to move 1, 2, so I can divide that and multiply 100. So this is 3.2%, and this is negative, sorry, so this is negative. And I'm going to round this, so I'm going to round this to 3%. So this is, or I can say 3%, and this negative becomes simply just decrease, right? Just like we did with our last problem. So we have a 3% decrease in this case. Yeah, so 3.2. I could also have done 3.23% just because I do have three digits here. So I would so the more correct answer in this case would have been 3.23%, and that's what I got in my calculator. But decrease obviously, but don't worry about that for now because we don't talk about significant digits in this course, I believe. So let's work with 21. So from 4,448 minutes, I'm going to do M for minutes, to 7,548 minutes. What is this? Pretty big numbers now. But they're not scary, you just choose calculator, right? You're just dividing two numbers, subtracting, right? These are operations we already know how to do. So we have this is a percentage increase, right? So let's do, sorry. Hold up. Oh no, my pen stopped working. Oh, that's so weird. Oh no, my pen stopped working. Sorry, some technical difficulties. Just give me a second. But you can think about, okay, what's my first problem here? I have percentage. This is a percentage increase, right? So oh, it's back. We have percentage increase, right? So let me write that down. Oh, the sensitivity is kind of wacky here. So this is percentage. This is increase. Wow, this is my pen's being really wonky today. I don't know what's happening. I think it reset to the sensitivity, so I'm gonna see if I can switch my sensitivity for this this here. Sorry, just give me a second. So this is a percentage of percent. I'm gonna type this out. This is percentage increase, and just hold on for a second. I'm just gonna have to do some settings. So let me a second. So this is let me do some settings. I don't know if that helps. Maybe this is a mouse. No, I don't think so. Give me a second. Error. Oh, never mind. I'm gonna get error. Okay, never mind. I'm gonna see if I can just maybe just be very, very careful with my mouse. I'm so sorry about this. I might just have to use my mouse, so that's unfortunate. But what we're going to do is we're going to subtract the two numbers, right? We're going to do 7,000. Oh yeah, it's really hard to write with this now. 7,548 minus 4,448, right? Yeah, I think I'm just going to use my mouse. I'm so sorry. My writing might be really bad in this video, so I'm super sorry for that. So 7,540. Oh, that's even worse. 8 minus 4,448. And what am I going to get? I'm going to use my calculator, and then I'm going to put 7,548 minus 4,048 is 3,500. Oh no, the mouse sucks. 3,500. I really hope you can see that. So I'm so sorry. 3,500. Let me erase this thing. put 3 here. It's 3,500. So now after that, I'm taking my difference. I'm going to divide it by the initial rate. So I have 3,500 divided by, this is the initial, which is 4,048. And that's going to equal 3,500 divided by 4,048. I'm going to get 0.865. Actually, I'm going to take 4 decimal places. I see 4. So 8646. So how am I going to convert this decimal? I have to convert this to a percentage. I have to multiply by 100%. So I'll do that here. So 0.8646. It's actually not that bad. I'm getting used to this. Times, this is 100%, which will give me, again, this decimal is going 1 and 2, right? So I get 86.46%. Or I can round this simply to 86%. And this is a percentage increase. So I can say increase. Wow, it's really hard to write with the mouse. So 86% increase. I'm so sorry for my writing. I'm going to leave you actually with 23 for a couple of minutes so I can actually get this fixed. So I'm super sorry about that. But I'm going to show you, I'm going to write down. Actually, I'm going to show you this problem here. This is number 23. If you're watching at home, please let me know. Please, you can help me figure this out. But while I work on this problem here, so just give me a second while you think about the problem at home. I'm going to try to see if I can fix my tablet real quick. So let me just do that. And in about 2 minutes, I'm going to take this up with you, whether or not my pen works. So let's do that. I think I just have to install my driver again. I'm so sorry. So again, is this a percentage increase or percentage decrease? Like, what are the numbers saying in this case? This would be a percentage increase, right? I have here, this is 4,359, sorry, 4,359, and then it's going to be to 5,377, right? So it's a percentage increase. So my first solution to this problem first is I'm going to have to, I will have to find the difference, right? So I have to subtract both of these numbers. I don't want to restart my computer, but I think I might need to. So I guess I cannot fix this problem without stopping the stream. So what I'm going to do is I'm going to just continue without it for now. Yeah, let me try now. Does that? Yeah, I'm going to have to restart my computer. So I'm just going to continue the lesson with my pen, unfortunately. I think. Yeah. So I'm going to try writing this again. This is 4,000. Yeah, actually, I'm just going to use my mouse. It's not worth it. So this is 4,359. 359. This is feet, and this is going to be to 5,377 feet. And again, I told you already, this is a percentage increase, right? So this is percent. I'm just say I for increase and D for decrease. Minimize my writing. So I'm going to take the difference here first, right? So this here is this 5,377 to 4,359. Little difficult to read on a phone. Yeah, I'm so sorry. It's just my pen, like this tablet here, just like literally malfunctioned on me. So I'm gonna try to use my mouse. Like I think I tried to install a driver here, but it told me to restart the computer, so I'd have to stop the stream. So I think for the rest of the, I think half an hour we have together, I'm probably just going to use my mouse, if that's okay. I'm going to try to maybe talk more and maybe do some typing to help you kind of, to help you visualize this stuff, I might have to resort to typing. So this would be, actually no, I think it's fine. Unless the typing, the font is kind of small as well, so I don't really want to use that. So I'm finding the difference between two numbers, right? So I have 5,377 feet minus, this is 4,359, right? I'm taking the final and the initial. Oh, you can see that with the text is really small. Yeah, okay. So maybe because I can't actually adjust the font size, so maybe I'll just use my mouse. So that's totally fine. It's just gonna be a pain for me because I really hate using the mouse, but it's totally fine. I'll do it for half an hour. So we're finding the difference, right? So 5,377 minus 4,359. This will equal 1,018. So 1,018. And then what we're going to do is we're going to divide the difference by with our initial, right? So let me scroll down here. So this here's our difference. 1,018 is our difference. So 1018. We're going to H is really hard on the mouse. There we go. Divide by the initial, which is 5,377, right? And that's going to give me, yay, math. I like math as well. 1,018 divided by 5,377. That's going to give me a decimal. It's going to be 0.18. Eights are really hard to do with the mouse. Oh, there we go. That's a good one. 8,993. And then I'm taking, again, 4 decimal places. And then all I'm going to have to do with this decimal is going to multiply by 100%, right? So I'm going to multiply this by 100%. And that's going to give me, sorry, I'm going to move this over for you. This is going to give me, I'm going to move the decimal 1 and 2. So it's going to give me, let's see, 5,000. Is this right? Wait, hold up. 5,370 minus 4,359, right? That's 1,018. Okay, good. I'm dividing by the initial. It's going to be 18%. 18.93%. Shoot. Percent, which will equal about 19. That's fine. 9's really bad. 19%. So that's going to be my answer for this question. I think if you scroll down, there's answers. But I think we have the wrong answer in this case. 4,359. I don't think I did my math wrong. 1,018. Oh, I did do my math wrong. Yes, I see here. I divided by the final, not the initial number. I have to erase this. Sorry about that. So I caught my own mistake here. Sorry. So the mistake I did there was I divided by this final number. I was supposed to divide by the initial here, which was 4,359. Sorry, let me write that down real quick. And let me redo my math. This is 1,018 divided by 4,359. This is 0.2. Oh my gosh, 2335. I'm going to multiply that by 100% to give me. It's going to give me. It's going to move this 1 and 2, so I get 23.35%, which I can round to 23%. So that's going to be my answer for number 23. Wow, that took so long because I had to use the mouse and I made a mistake, so I'm so sorry about that. But this is 23%, which is the correct answer here. So I hope that's kind of just a little bit about percentage increase and decrease. So that was kind of the lesson for today. But what I'm going to do is I'm going to work backwards. I'm going to go back to, we did equations last time. So I'm going to do a review of maybe I'll do a problem with multi-step equations, and then we'll move on to new materials. Let me just review multi-step equations with you. I'm going to pick, which one I didn't do last week? To figure that out. I didn't do 19. Let me do 19 here. 19 in this case. I just divided 5k by 4k and forgot the first one. Actually, that works as well, actually. So thanks for Ali. So thanks for selling that. There's actually a lot of ways to do percentage increase and decrease here in this case. So what you can do is you can actually divide the both numbers. So you can divide 5,300 377 divided by 4,359, and you're gonna get 1.23, and you can subtract 1.23 by 100%, and you get 23%. So there's actually two ways to do this, and you can do whichever way you want, and that works as well. But when we're talking, we want to, and then what we need to do is we also have to justify if it's percentage increase or decrease, and you can always look at the numbers and do this. So again, there's two ways to do this. There's a lot of ways to do math. Again, math is kind of weird like that, where sometimes if you think about problems in different ways, it actually gives you the right answer. So yeah, you can definitely do that way as well. I always just brought up with this way, so that's how I see a difference and change, and then afterwards I put into a percentage. But you can definitely take both initial and final numbers and divide them, and then find the percentage that way as well. So it totally works as well. So thanks for bringing that up. So I'm gonna do 19 here. And this is just a review of multi-step equations. And I feel like I'm going to be really slow with this because now I'm with the mouse. So 24a minus 22 equals, and then I have negative 4 times 1 minus 6a. So again, this is multi-step equations now. Multi-step equations. Maybe going slower is a bit easier as well. So maybe if you're kind of if you're kind of like following along here, maybe if I go slower, it might be a bit easier for you as well. So I'm gonna do this in blue. So what's my first step here in this equation? 24a minus 22 equals negative 4 times 1 minus 6a. My first step here is I'm going to have to use distributive property. Remember this concept of distributive property? I have an outside bracket and an inside bracket. I'm going to have to distribute or spread evenly this negative 4, right? This is outside the bracket and this is inside the bracket. So I'm going to do distribute negative 4 into the first person here and into the second, I don't know why I said person, second term here as well. I like your mathematics. It honestly, it really depends on personal preference. Like on a test, like if you ever ask percentage increase or decrease questions, if I marked it, if you used my method, if you used another method, if you got the right answer, and if you showed your work and it's valid, I would have given you marks. It doesn't really matter which method you use. I just have my own and you have your own, so totally fine. Math is math, so it's totally cool. Okay, so I'm going to distribute this first. So I'm not going to touch the left side. So I'm going to simply do this. Is still 24. Clearly can't do letters. Minus 22 equals, so I'm distributing negative 4 times 1 here is negative 4. Negative 4 times negative 6 here is positive. This is 24a, right? Two negative numbers make a positive number. So 24a as well. So now what I have to do is I have to gather like terms, right? I see an a term here and an a term here. So I can gather this term and this term. And then I see my constants are also terms, this term and this term here. So let me work with I'm working from left to right. So let me work with the variables first. This is on the left side. So 24a, if I want to bring 24a into the other side, what do I get? I have positive 24. I'm going to have to subtract both sides by 24a. But if you look at what happens here, 24a minus 24a, and this here is still negative 22 equals minus 4. And these two cancel out to 0. I have here 24a minus 24a. This here cancels out to 0. So in this case, I have negative 22 equals negative 4. So that's not right. That's not math. This is bad math here. So what happens here? What does that mean? It means that my solution has no solution. So in this case, a here has there's no solution. No solution. I can't type with this. No solution. So there's no value of a that satisfies this equation. And I can actually, there's a lot of answers that have no solutions. And in this case, 19 is also no solution, right? And that's how we prove this. If we have ever this kind of expression here that does not make sense, like negative 22 equals negative 4 is not a valid equation, or not a valid equation, right? Negative 4 equals negative 4. Negative 22 equals negative 22. The numbers can't be different numbers, right? So this here verifies that we have no solution. So let me do actually one with solutions before because that one was kind of a buzzkill because we have no solution, so that's not very nice. I'm trying to pick one that has a solution for you. Let me do 14. So let me do 14. I'm just trying to do it in my head before I give you the problem. So hopefully it has an answer for you, and I'm pretty sure this one does. Yes, this one will have a problem. Yeah, this one will have one. I just solved it. This one will have a solution for you. This equals, this negative 2 times 1 minus 7n. Sorry. Okay, so 5n plus 34 equals negative 2 times 1 minus 7n. Again, what I'm going to have to do is I'm going to have to distribute my variables. I'm going to have to distribute, not my variables, distribute the property, right? So again, outside bracket times inside bracket, right? So outside bracket is negative 2. I'm going to have to distribute this into the first term, distribute this to the second term. I need a finance tutor. I think there's actually courses here on OneClass that actually provide courses on finance. I don't teach it personally because I'm more so math and chemistry, but you can definitely check out OneClass, and if they have tutors, you can definitely hit them up and maybe send them an email or something, and I'm pretty sure they can help you arrange that as well. So again, negative 2 here. So I'm not doing anything with the left side. So 5n plus 34. Oh my gosh, my 4 sucks. 34. This will equal, again, at the first term, I have negative 2 times 1 here, right? So negative 2 times positive 1 is simply just negative 2. Negative 2 times negative 7 here is positive 14, right? So positive plus here 14n. So positive 14n. And then again, what I can do is I can collect like terms. I see an n term here, an n term here, and I see a couple of constants. It's 34 and negative 2 here, right? So what I can do is I'm working from left to right again. Let's do my variables first. So 5n and 14n here. If I want to move 14n to the other side, what I need to do is I'm going to have to do the opposite operation, right? So I'm going to have to, instead of plus 14, I'm going to subtract 14 from both sides. So if I do minus 14n on this right side, I'm going to have to minus 14n on this side, right? So I'm going to have 5n minus 14n. And then this is, I'm going to write my constants in red. So 34 equals negative 2. I didn't do anything. Right, 2, please. Okay, negative 2. And then I have to do this. I can combine like terms. I can gather like terms. Now 5n minus 14n. 5 minus 14 here is negative 9. Is it negative 9? 5 minus 14 is negative 9. Yes, all is good in the world. Negative 9, n, and then what I can do is, this is still plus 34 equals negative 2. And then what I can do is that I can bring the constants to the other side, right? I want to be able to isolate from my variable. So if I want to have positive 34 in this case, I'm going to have to do the opposite operation. So subtract 34 from both sides. So again, all I'm left here is with, I'm doing some blue. This will be now negative 9 n equals, and then here I have negative 2 minus 34, right? So I'm subtracting 34 from both sides. This will equal, negative 2 minus 34 is negative 36. And then I have, this is still negative 9n. And the last thing to do with these two terms, I have to get rid of this negative 9 from the side. I have negative 9 times n. I'm doing the opposite operation, so I'm dividing both sides by negative 9 in this case. So all I'm left here on this left side is n equals, this will be now a constant, so negative 36 divided by negative 9, which means n would equal negative 36 divided by 9. These negatives cancel out, so it's just 36 divided by 9, which equals 4. So n here in this case equals 4, and that's going to be our answer for number, this we did number 14 in this case. So n equals 4 is my answer. So that's what we did in our last lesson. That's just a little review of what we did, and what we're going to do is we're going to use this knowledge and we're going to actually apply this to an absolute value equation. So let me figure this out first. So what is an absolute value equation? So let me write this down. This is absolute value. So I'm going to first define what absolute value is. So what is an absolute value? So an absolute value is simply just, what it usually notes, it denotes this as this 2 bars. There's 2 bars and then something in the middle. So 2 bars and then x. So for example, this, if I were to define this or say it out loud in this case, this would, it's not just bar x bar, it would simply be the absolute value of x. So absolute value, oh no, value of x. So absolute value of x here. So what I have here is the absolute value of x. And what does that mean mathematically? It means that whatever x can be, if it's positive or negative, these absolute value bars just simply cancel out those that value. So for example, if I have the absolute value of 1, the absolute value of 1 will equal 1. However, if I have the absolute value of -1, this will equal 1. So basically, I'm taking another way of thinking about this is I'm taking the magnitude of whatever is in the lines. So you can say absolute value of x, but a lot of in physics, for example, we like to take the magnitude of something. So that's actually what the absolute value is, and that's what it is here as well. So how do we use this in our equation? How do we solve equations with absolute value bars? So let's do number 1 together. Number 1, so this is absolute value of 6m equals 42. So how would I solve for m in this case? Well, I solve it just like any other equation, right? I have to isolate from my variable, right? I see here absolute value bar is 6m. What we can do is we can actually let's not worry about these absolute value bars. Let's just look at the 6 first. How do we isolate and how do we get rid of the 6 on the left side? If I have 6 times m, what I need to do is I need to divide both sides by 6, right? So I'm going to have just absolute value on m on this side, and this will equal 42 divided by, and this will be divided by 6 here in this case. Divided by 6, right? Divided by 6. So again, let me just ignore the absolute value bar in this case. M would equal 42 divided by 6. What's 42 divided by 6? This would just be 7, right? So m here equals 7. However, I do have to include this absolute value bar. If I have m equals 7, in this case, it has to be positive. But if I multiply, and that's my record, if I multiplied 6 by -7, I would still get 42, right? Because remember, anything that's in the absolute bar is going to become positive, right? So if I have, for example, so this answer would be 7, but this will be plus or minus 7. So I'm going to do plus or minus 7. And I'm going to introduce to this concept. This here is plus, the words plus or minus. And this is the notation for that. Plus or minus 7. And if I wanted to check my algebraic equation, so again, I'm substituting this back for m. What I can do is I can realize that I have 6 times positive 7, and the absolute value bar that equals 42. Oh my gosh, 42. 6 times 7 equals 42, right? And what I have absolute value bar equals 42. That's correct, right? So 42 equals 42. So that's a correct answer for positive 7. But what about for -7? And this will prove to you why it's plus or minus. So the absolute value bar of 6 times -7 equals 42. I have 6 times -7, in this case is positive negative. I have -42, right? So the absolute value of -42 equals 42. But remember, these absolute value bars, it gets rid of the negative for me. So these absolute bars, what it does is it gets rid of the negative. So I'm just left with 42 on this side, which equals 42. So this is also a valid answer, which means my answer, absolute value bar of m, has to equal plus or minus 7. And that's going to be my answer for this one. If you just write positive 7, you're going to get the answer wrong, or you're going to get only part marks. You need to also acknowledge that -7 is also an answer to this solution, like I did with my check. And again, these two parts were just a check, right? So this is a check. Oh my gosh, my writing. This is just a check for these two things. So let's do 3, and let's keep moving down. Let's keep moving down. So this here is 3. So this is k minus 10, or absolute value bar of k minus 10 equals 3. So again, maybe take a moment to figure this out. How would I solve for this this question here? How would I solve for this equation here? So again, I have an absolute value bar of k minus 10. What I have to do is, again, I have to isolate for this k, right? So I have to isolate for this. So I'm going to have to move this negative 10 to the other side, right? So if I move this to the other side, normally, without the absolute bar, I'm going to get, in this case, negative 10. I'm going to have to add 10 to both sides, right? So I would get absolute value bar of k. Actually, I'm gonna spoil this for you for a sec. I'm gonna give you a rule here, and basically every time I have something that's a positive or negative in this case, every time I bring it out of an absolute value bar, I have two solutions. So what I mean is I'm gonna have two parts. I'm gonna have to assume that this here is normally it's going to be k, or absolute value bar of k would equal, would be 3, and then I would add 10 to both sides, right? Plus 10, right? However, in an absolute value bar, the rule is if I take this negative 10 out, I would also have to do the opposite, or I would also have to do the same operation. So not the opposite operation, but the same operation. So in this case, k could also be equals 3 minus 10. So I'm going to subtract 10 from both sides. So that's kind of a rule that we use because I'm going to have two solutions, and I'll prove to you why we have two solutions to this problem. So this here, I'm going to solve absolute value bar of k equals, this is 13. So which means k here equals 13. And the absolute value bar k equals, this is 7 here. Or sorry, negative 7. Negative 7, and then if I put the absolute value bar to the other side, I'm going to have to, this number is going to be positive, right? So I have k equals 7, which means here I have two solutions to my problem. Look, I have two solutions of k equals 13 and k equals 7. And I'm going to prove to you why we have two solutions here. So we have k, let's see, we have k, and I'm going to do a check in red. So I'm going to sub 13 into the k here. So 13 minus 10 equals 3, the absolute value bar here. 13 minus 10 obviously equals 3. Absolute bar 3 equals 3, and that's correct, right? 3 equals 3. So all is good in the world with this problem here. However, I'm going to check now with this k equals 7, right? So I'm going to sub this k equals 7 into my equation, and let's see if I get two solutions for this problem. So I can see here, this will be absolute value bar of 7 minus 10 equals 3. 7 minus 10 in this case is negative 3. So absolute of negative 3 equals 3. This absolute bar again gets rid of the negative for me. So I have 3 equals 3. So this here is a check as well, which means in this problem, I have two solutions, just like this one. I have plus or minus 7. Plus and minus 7 are both solutions in this case. And in this case, I have different numbers. K could be 7 or k could be 13, right? So we have two solutions that satisfies this equation here. So that's number 3. And again, this gets kind of tricky because what we have to do is we have to acknowledge that two solutions may be present, two or more solutions may be present in this problem. So that's number 3. And that's what we get when we get a lot of absolute kind of equations here. Most of the time, some of the times we're going to get solutions with one or two, equations with one or two solutions. Let's do number 5. So we have absolute value 7 plus p equals 7. Okay, so how would I solve for this? Again, so maybe take a moment to pause and think about this problem. I have the absolute value of 7 plus p equals 7. So what I'm going to have to do first is I'm going to have to move the 7 to the other side. But remember, this is a imaginary positive 7 in this case. If I move it to the other side, it's going to be ideally negative 7. But remember, I have the absolute value bars here, which means I'm going to have two solutions. And you got it. This is a two solution problem. So which means for this problem, I'm going to have to do absolute value of p equals, this is 7. And this will be, instead of plus 7, I'm adding 7 to both sides. Operation is negative 7. So I will subtract 7 from both sides. And this here, I'll solve for this part here. So absolute value bar p equals 7 minus 7 here is 0. And then p here, in this case, I move absolute value bar to the other side. It's still 0, right? So p equals 0 is my first solution in this case. My second solution, I have absolute value of p equals, I have 7 here. And what I'm going to do, 7 here, is going to plus 7, right? I'm going to add 7 to both sides. I'm doing the same operation on both sides because of this absolute value bar. 7 plus 7 here in this case. And then what I'm going to do is p here, absolute value bar of p equals, this is 14, right? 14. And if I move this absolute value bar to the other side, it's actually, what it's actually going to do to this number is actually going to make it negative, which is kind of wonky here, right? So, because you can think of it as you're multiplying it by -1, right? Because remember, if the absolute value cancels out something that's negative, if I put absolute value bar into something, it's going to grant it a negative, right? So I'm doing the opposite operation. So in this case, p here equals, instead of positive 14, it'll be negative 14. So this here is a tricky one, because what if I plugged in positive 14 in this equation? I have 6 plus 14 in this case. 7 plus 14 here is 21. 21 equals 7 is not correct. That's not a solution. However, if I plugged in negative 14 here, you're going to realize that this is a solution. And I'm going to check my work real quick in blue. So if I plugged in p equals 0, if 7 plus 0 is 7, absolute value bar of 7 is 7. That's cool. All is good in the world. P equals negative 14. This is a bit trickier. 7 plus negative 14 is negative 7, but the absolute value of negative 7 is 7, right? So that actually satisfies my equation. So in this case, 7 equals 7. So again, I have two solutions. I have 0 and negative 14 is my answer for number 5. So let's, I don't know if we're going to get to radicals today, but let's maybe work on 2 more solutions. Maybe let's do 15 and, or actually let's do a fraction. Those are fun. Let's do maybe 16 and 18, and then we'll call it a day for today. I'm so sorry about the the tablet issue. I'm going to get it resolved as quickly as possible right after this video. So for next lesson, it'll be totally fine. I have the absolute value of x over 7 minus 8 equals negative 7. So again, how am I going to solve for this equation? So firstly, again, I'm doing the reverse order of PEMDAS, right? So I'm going to have to get rid of this negative 8 first. So again, reverse order negative 8, opposite operation of negative 8 is positive. I'm going to add 8 to both sides, right? So I have the absolute value bar of x divided by 7 equals, this is here negative 7, here's plus 8, right? I'm adding 8 to both sides. What I'm going to get is x over 7. Oh, that was really good. Negative 7 plus 8 here equals 1 in this case. Or not in this case. In negative 7 plus 8 equals 1. And then what I'm going to do is I'm going to have to now do something with this 7 here. I'm going to move it to the other side, right? So I'm going to say the absolute value of 7 here, or sorry, of x here equals, this is 1 times 7, right? Now, in this case, I'm going to, actually, no, I'm so sorry. I have 2 cases. I totally forgot. I have here 2 cases again. I have to do an operation inside the absolute value bar, which means I'm going to always have 2 cases. So I'm going to have to, my first one here is I have x, absolute value bar, x times 1 times 7 here. And then I'll solve this one first. So this here, absolute value bar of x, 1 times 7 here is 7. 1 times 7 is 7. I move the absolute value bar to the other side, which means I'm going to have x equals negative 7, right? X here equals negative 7. And then here, I'm going to have my second case. I have absolute value of 7 equals, this is 1 times negative 7, right? Because negative 7 is also a factor, right? So this is because I have the absolute value bar here. So this will be, you have to multiply by negative 7. Absolute value bar of here equals negative 7 in this case. If I put the absolute bar on this side, x here equals positive 7. So again, I have 2 solutions. 2 solutions to this problem. I have x equals negative 7 and x is positive 7. And so again, 2 solutions to this equation here. Sweet. And let's do 18 as my last problem here. Let's do 18 and then we'll wrap up for today. This is negative 10 times the absolute value of v plus 2 equals negative 70. Negative 70. So again, reverse order PEMDAT states that we do actually do this absolute value bar, but you can think of this absolute value bar as a parenthesis. You can think of this imaginary parenthesis going here, because this negative 10 is multiplied by this entire term here. So what I'm going to do is I'm going to have to move negative 10 to the other side first. Let me do that. This is v plus 2, absolute value of v plus 2 equals, this is now negative 70. If this is multiplied by 10, by negative 10, I have to divide both sides by negative 10, right? Do the opposite operation. Absolute value of v plus 2 equals negative 7. Divide by negative 10 here is positive 7. And then what I'm going to have to do is I'm going to, again, if I were to bring this to the other side, I have to break this into two cases now, right? So case 1 and case 2. So case 1, I have the absolute value of v equals, I have 7 here, and plus 2 operation, the opposite operation of plus 2 is minus 2, right? Minus 2 in this case. Right? Yeah, minus 2. Absolute value equals, I have here 5. Is that correct? Hold up. Is that 5? Am I mixing up something? 7 minus 2 is 5. Yes. And then this here is v here can be either plus or minus 5, right? This v could be either plus or minus 5. And let me just check. I'm gonna have to check both answers with you right now. So let me just check that. Let me check that this satisfies this equation. So if I plugged in positive 5, I'm going to have 5 plus 2 equals 7. That's good. If I plugged in negative 5 plus 2 equals 7, that's not correct, right? Negative 5 plus 2 does not equal 7. Negative 5 plus 2 here equals negative 3, which means in this case, my negative is not an answer. I have to go back and check it. So this is why I always check my work in the beginning, because what if you get something that's like this algebraically shows that this answer can be positive or negative 5, but in the equation, only one of them might satisfy this equation. So in this case, it's only positive 5 that works. Let's do this case. So this is absolute value bar of p equals, this here is 7. I'm going to add 2, right? Add 2. 7 plus 2. Absolute value bar here, 7 plus 2 is 9. And then v here could equal, again, v here could equal plus or minus 9. So let me, again, check both cases for you. If I add plus 9 to this, 9 plus 2 equals 11. So in this case, positive 9 is not an answer. But let's check negative 9. So is v equal negative 9? So I have negative 9, sub that back into v. Negative 9 plus 2 equals 7. Negative 9 plus 2 equals 7. The absolute value bar of negative 9 plus 2 equals 7. Negative 9 plus 2 is negative 7. The absolute value of negative 7 is indeed 7. So in this case, v is negative 9 and v is positive 5. And those are my answers for this problem. So again, what we have to do with these questions is we have to be very, very careful. We have to go back and definitely check our work. I did that in our previous video because I want to ensure that we got the right answer. But in this case, for absolute value, we always have to check our work, because sometimes we get a lot of these cases where only positive 5 works and not negative 5, right? So we need to be wary about these exceptions and these, so we always have to check our work is kind of my takeaway here. Let me do a little review of what we did today. So again, we did absolute value functions. We talked about how this absolute value bar, we only care about the number inside. So if a negative number inside absolute value, it's going to turn positive. If it was positive initially, it's always going to be positive in this case. And what I'm doing is sometimes we have two cases for each problem. So we have two cases in this problem, and what we're going to do, we have to break down this equation into two different cases. And sometimes we get two different answers, like this problem here. We reviewed multi-step problems. So again, we talked about distributive property and gather like terms. And then the first half an hour is we did introduce the concept of percent of change. So I hope you enjoyed this video on these topics. What we're going to do cover next lesson, not tomorrow. Next lesson, we're going to look at radical equations. This is the easy one. And then obviously we'll do some hard ones as well. So stay tuned for that. And as always, thank you for watching and have a great day.